Hey guys, Travis Gillespie. We've been talking about intercepts, and well, intercepts have a variety of interpretations, and I'm going to share some of those with you. Let's just going to zoom out here. Let's take a look at a real world application here. Cool. So let's take a look at the following problem and see intercepts happening in real life. So a runner is participating in a 7,000 meter race, and their average speed is 100 meters per minute. The function f of x equals 7,000 minus 100x gives the runner's distance in meters from the finish line after x minutes. Graph this function and find the intercept. So that's your mission here, is to graph the function and find the intercepts. And then as an added postscript, find what the interpretation of each intercept is. So to do this, I've set up a little table here um, where x equals 0, 10, 30, and these are actually in minutes. So what I'm going to do here is, hey, x is in minutes. Let's see if that popped not really too well. Looking for a dark color. But I know that, hey, x is in minutes. We'll just write minutes, min for short for x. And then, again, as stated earlier, f of x equals 7,000 minus 100. X is the distance. And just an added note, neither the time nor distance can be at negative numbers. This is a real world application where neither time or distance can be negative numbers. Therefore, choose values that are positive. Or said another way for this scenario, choose non-negative values for x. And I've done that here, 0, 10, 30, 60, 70. Let's work on the first one here. I have x equals 0. So f of 0, that means whenever I have an x, I'll plug in a 0. Well, 7,000 minus 100 times 0. So what I'm really left here is 0. So what I'm left with is 7,000. So when x is 0, I have 7,000. So let's move on here. So I have 10, x is 10, so f of 10, well, that's 100 times 10, which is 1,000. So 7,000 minus 1,000 equals 6,000 here. And, well, for 30, I'd have 100 times 30 is 3,000, so 7,000 minus 3,000 will be 4,000. 60 times 100 is 6,000. 7,000 minus 6,000 is 1,000. And finally, 70 times 100 is 7,000. 7,000 minus 7,000 is 0. Cool. Okay, so now using these points, let's see if you can actually produce a graph. So for x equals 0, for f of x, or f of 0, I have 7,000. So my first point that I'm going to graph here is 0 and 7,000. Wow. Hold the phone. Stop the presses. I've just found the y-intercept right here. The y-intercept is at 7,000. Why? Because it crosses the y-axis at 7,000. So let's go through and graph these final ones. So at 10, I'm at 6,000. And make that a little bit higher. At 30, I'm at 4,000. At 60, I'm at 1,000. And finally at 70, I'm at 0. And you see at this point, again, the big picture, or the big or interesting fact here is that I am crossing the x-axis at 70, so that means it's telling me, hey, the x-intercept is at 70. And over here, the y-intercept at 7,000. Now let's draw this graph by connecting. I'm going to connect the dots here. But the big picture, the big point is I am not going to extend this graph past these points because it's a real world application. See, this is where the race ends. The distance from the finish line is at 0. So there's no need to extend it past this point. The person's not going to keep running. It's not like the Energizer Bunny when the commercial, keeps going and going and going. When this woman crosses the finish line, she stops. It's the end of the race. And similarly, you can't go back in time, so you're not going to have negative time. She's not going to go back in time and continually run either. So it starts here, ends here, and that's it. Duration of the race. Well, we found the intercepts, but the last part of the question says, hey, what does each intercept represent? Well, let's think about it. Well, 7,000 here, well, that's the y-intercept, so get a new pen here. This is the y-intercept. 7,000, well, that's the distance that's in front of the woman as she starts the race. So that's how much she has in front of her still. So this is the distance from the finish line. And then the x-axis, or x-intercept, let's see what that is. Well, the x-intercept here being 70, and actually the y was, 7,000. So the x-intercept is, well, if you think about it, this is the time it took for the woman to have 0 distance in front of her to finish the race. That's really a weird way to say, hey, this is how long it takes. It took her 70 minutes to finish the race. So the x-intercept here is, well, this is the time when the runner reaches the finish line. So the x-intercept is how long it takes to finish the race. The y-intercept is how long the race is total. Neat.